So another method of physical testing is delamination testing. Delaminations are cracks that occur below the concrete surface, typically at the location of the upper reinforcing steel. So delaminations look something like this. So the delaminations typically occur below the concrete surface and on the upper part of the reinforcing steel. So in actual, delaminations look something like this. They actually occur beneath the concrete surface. So we can also see this in our home, on our floors, and other concrete components of a particular structure. So these delaminations can actually affect, they can actually affect the strength of the particular component that that particular component where the delamination occurred. So they must be detected immediately so that proper rehabilitation or maintenance can be provided to them so that uh, the effect of the delamination will be reduced if not totally eliminated. The most basic method of testing is to use a hammer and sound for hollow spots. So in actual, we usually locate the particular places where there are delaminations by using a hammer. We are we are using a hammer on the concrete surface and sound for hollow spots, because this hollow spot sound can actually manifest that there are actually delaminations beneath the concrete surface. So we usually tap the upper surface. We usually tap the surface of a concrete using a hammer, and then uh, try to hear for hollow spot sounds. So whenever we detect hollow spot sounds, it can manifest that there is there are already delaminations beneath the concrete surface. Therefore, that particular location needs to be rehabilitated already. Obviously, such a method is quite time consuming, and for large surfaces such as decks can prove impractical. As an alternative, a chain can be dragged along the deck surface to cover a greater area, but surrounding noises may make it difficult to detect hollow sounds. So the use of hammer is obviously time consuming to detect the location of delaminations, especially if we are dealing with large surfaces such as decks. So an alternative to the use of hammer, we usually use a chain like this one and drag along the surface of the concrete so that we can easily detect for hollow spot sounds. So again, just like for the case of using a hammer, whenever we detect a hollow spot sound, that can manifest that delamination already occurred beneath the concrete surface. So we usually mark that particular location where we detected a hollow spot sound and record it so that it will be subjected to maintenance or rehabilitation. To facilitate delamination detection, machines based on the acoustic method are available. Typically, it is walked by the inspector like a lawnmower, or it is mounted onto a vehicle, recording delaminations as it travels along the bridge deck. So as you can see here, the use of chains to detect delaminations uh, can also be disadvantageous because uh, the surrounding noises coming from the vehicles traveling that particular highway or bridge can affect the detection of the hollow spot sounds. So therefore, it will make the detection process difficult for the bridge engineer or the person conducting the delamination testing. So as an alternative again to that uh, method, we can use delamination detection that are mainly based on the acoustic method, wherein the inspector will just walk along the concrete surface, a particular machine, which looks like a lawn mower, or maybe it can also mounted onto a vehicle, and then as it travels along the highway or the concrete surface, it can already record the laminations as it travels along the bridge deck. So that's an alternative to the use of chains and hammer in detecting hollow spot sounds. Infrared thermography is used to look for voids beneath the surface by measuring the temperature differential that exists due to the presence of moisture at a void. Ground penetrating radar, which can detect voids and delaminations in concrete, has also been used for concrete deck inspections. So these are more of modern technological advancement in the detection of delaminations. So we can also use infrared thermography or ground penetrating radar to detect voids beneath the concrete surface, because these voids can actually manifest that there are delaminations occurring beneath the concrete surface. So if you will try to look on an infrared thermography, this is just a small device like a camera that can be used to detect the the temperature differential that exists due to the presence of moisture at a void on a particular concrete surface. Therefore, uh, it helps to detect the location of delaminations. So that is again another method for physical testing, the delamination testing. So again, we usually conduct delamination testing to detect the locations of delaminations or the cracks that occur below the concrete surface, because these delaminations again can affect the strength of our concrete component of our bridge or highway structure. Therefore, it needs immediate action or attention and immediate detection. And we can conduct delamination testing to immediately detect the locations of delaminations.